We're on page 77, and here we're going to do examples of rational expressions and use the rules that governing rational expressions that we did on page 76. So these are specific applications of examples of what we discussed in the previous video on page 76. So we're going to go over 5 different examples here, and most of them involve some kind of simplification. And so let's start with the first one. They're reasonably easy to understand. Here we're asked, example 1, consider the fraction x minus 1 divided by x plus 1 evaluated for x equal 1. So this simply means that everywhere that x appears in this equation, we replace it with 1. So in the top here, we'll have 1 minus 1 because this x is replaced with 1. And here in the denominator, this is replaced with 1. So we have 1 minus 1, which is 0, 0 over 2. When 0 is in the numerator and a number in the denominator, the answer is 0. So this is equivalent to saying 0 times a half. 0 over 2 is really equivalent saying 0 times 1 over 2. Now, find the value or values of x for which it is undefined. It will be undefined if this denominator is 0. That's the only thing. And so what we have to do is set this equal to 0. And x is minus 1. In other words, if x is minus 1, then minus 1 plus 1 is 0. And 0 on the denominator would make the fraction undefined. So find the value of x for which it is defined. Sometimes if we have more complicated expressions on the denominator, we will have more than one value. Here, there's only, we set this equal to 0, solve for x. X is equal to minus 1. Hence, this expression is undefined at x equal to minus 1. Let's go to example 2. We have to simplify this. And this, we have to write the expressions equivalent to that. So we have to factor it. So we're going to factor this, and we're going to factor that. This is the difference of squares, x plus 5, x minus 5. This, we see it's x plus 1 times x minus 5. The first times the first gives me x squared. Plus 1 times minus 5 gives me minus 5. The inner is plus 1x. The outer is minus 5x. If I combine them, I get minus 4x. So now I can see that the x minus 5 is common to the top and the bottom, to the numerator and the denominator. I cancel these two expressions. Okay. And I'm left with x plus 5 over x plus 1. Okay, so first we have to factor and then cancel like terms on the numerator and the denominator. Number 3, we have an interesting fraction here, rational expression, where we have x minus y over y minus x. Now, what we're going to do is leave the denominator the same. So let's just leave the denominator the same. We're going to rewrite this as minus 1 times y minus x, because minus 1 times y gives me the minus y, and minus 1 times minus x gives me plus x. So I can just take out minus 1 as a factor here, reverse this term here, keep the same. Minus 1 times y, minus y. Minus 1 times minus x gives me x. Now, why would I do that? Because now I can cancel the numerator and the denominator, and I get minus 1. So essentially, you'll notice this term here becomes this term over here. This term here becomes this term here, and there's a minus here. In order for it, it will always reduce to minus 1. Let's say I have 3a minus 5b over 5b minus 3a. This term has become this one, and this one has become this one. Now, just to show it, I take out minus 1, like I did over here. Minus 1 times 5b gives me minus 5b, and minus 1 times minus 3a gives me plus 3a. So now I can cancel 5b minus 3a in the numerator and the denominator, and I get minus 1. So you see what happens here is that this term becomes this term, including the coefficient. This term becomes this term, and if that's the case, then the expression is equal to minus 1. The sign between the terms must be the same and must be negative for this to work. So here we're asked to multiply and simplify here. And here what we've done is take the x, that becomes this x. X plus 1 squared is x plus 1 times x plus 1. And here we have x plus 1. Instead of writing x squared, we've got x times x. Then we cancel the common term. So this x plus 1 cancels with this. This x cancels with that. And I'm left with x plus 1 over x. So that's just one way. There's another way to do this, and here's what it is. What we do is, what we're going to do is reverse these two terms. So we have x plus 1 squared and x plus 1 here. So we're just going to put this here and this there. Just interchange this one and this one. The denominator stays the same. Now both these terms are x plus 1, and this is raised to the power 1 here on the denominator. There's a power 1 implied. So I can bring it up and say x plus 1 to minus 1. Similarly, this is x to the power 1, this is x to the power 2. I can bring this down to the denominator and change it to minus 1. And 2 minus 1 becomes 1. I don't put the 1 here. 2 minus 1 becomes 1. I don't put the 1 there, but I get the same answer that I get over here. So it's really this is treated as one entity squared. And this is one entity, the same thing as this up here, but to the power 1. So I'm subtracting the powers, and that's why I get 2 minus 1. There's two different ways of doing that problem. Now, example 5. Here I have 2 minus x over 15 divided by x minus 2 over 3. What I can do is rewrite the first term right here, which is right here. And instead of dividing, I'm going to multiply. So I invert and multiply. This becomes multiplication. I put this up to the numerator, and I put this down to the denominator. I invert and multiply. Now, what I do is, okay, the 3 goes into the 15 5 times, so I'm left with a 5 here. So 3 goes into the 15 5 times. Notice, this term is this term. This term is this term. And so this becomes minus 1, just like we did before, because minus 1 times x is minus x, and minus 1 times minus 2 is 2. So this whole part here becomes minus 1 right here. 2 minus x divided by x minus 2 is minus 1, and I'm left with minus 1/5. So that completes the 5 examples on page 77.